Alright, so we're going to solve. Yes, we did. We are going to solve exponential equations using logarithms. So the first thing we're going to look at is just some basic equations. You've got a number raised to a power of some unknown quantity and equal to another number. So how we solve these is we put them in log form. So this would be log base 7 of 12 equals x. And then we just have to evaluate this log using the change of base theorem. So you could just do log of 12 over log of 7. And so you put that into your calculator, log of 12 divided by log of 7. And it comes out approximately 1.3. It's like 1.276. I'm going to round it off.
Will you give us points off if we don't do the little squiggly equal signs?
No.
Okay.
Also, Parker, that's called an approximation.
All right. Shh. Let's rewrite this one in log form. So we have log base 3 of 11 equals x. So then if we rewrite it, it's log of 11.
Oh, these are other pairs.
Over log of 3. Shh. So we do log of 11 divided by log of 3. And it comes out 2.18, so I'm just going to round it off to 2.2. So those are the basic problems. And then what they'll do is they'll just add steps onto it where you have to get the part with the exponent by itself. So in the next box, these... Well, because we've been building up to it, you had to learn the change of base theorem first. It actually goes in a logical order. I know, crazy. All right, so on this part, you have to get the 3 to the x part by itself. So to get rid of the 8, we divide both sides by 8. You get 3 to the x equals 5/8. You could change that to a decimal if you wanted, but really we're just going to use it in our formula anyway. So this would be equivalent to log base 3 of 5/8. So you could use your calculator and do log of 5 divided by 8 for 5/8 over log of 3 divided by log of 3, and x comes out about -0.4.
Cameron's having mood swings.
Shh. Am I going to have to start this video over?
Ah, it's a good idea.
I did say that. Alright, so the next problem is actually exactly the same process. I just wrote it with the base in parentheses just to show you that it's the same thing. There's a 4 out here, and this part's got the power. Just divide by 4 to get rid of that. And then you have 2 to the x equals 5. And then you can put that into log form. So log base 2 of 5 equals x. And if you start getting where you do a lot of these, you could probably skip this step and go straight to change of base theorem, which I think when we did this last year, you guys did that. So it would be log of 5 over log of 2. You just have to remember that that's how it works. And that comes out about 2.3. All right, so we have one more that's kind of like this, but slightly different. You may have to rearrange equations to get the part with the power by itself. Sometimes there are extra steps in the power, like this one. The first thing you want to do is get the part with the power by itself. So how do I get rid of this 7? You would subtract it. Good job. So then we get 3 to the 2x minus 1 equals 147. So then when we set up our log, I'd have log base 3 of 147 equals 2x minus 1. So you can tell there's a couple extra steps there, but it won't be bad. So we would figure out what this is, log 147 over log of 3. And you could leave it like that for a moment. I think it'll be okay on this one to go ahead and figure that out. So we'll divide by log of 3. This comes out 3.49, and then that's equal to 2x minus 1, and then you just solve for x. So you add 1, you get 4.49 equals 2x. Divide by 2. 4.49 divided by 2 is 2.245. So it comes out about 2.25. I'll keep a couple decimal places here. If you're worried about rounding error, you could leave this as the log and put that into your calculator and then just push +1, enter, divide by 2, enter, and then round off on the last step. That's probably the best way to do that. And then there's a couple of review questions at the end that use E. So just remember that when you put these into log form, so we log base E of 12 equals x. Log base E is just the same thing as natural log. So really all you have to do is natural log of 12, which we have actually covered already when we talked about E, but I thought it was worth looking at again. So that would be about 2.48 if we round that off. And then they can also do extra steps with those. So this one has a 2 in front of it. So you get rid of that by dividing by 2, and you got e to the x equals 1.5, or you could leave it 3/2 if you wanted to. So log form would basically just be natural log of 1.5 equals x. You can do this in between step where you rearrange it if that helps you understand, but all we're going to type in the calculator is natural log of 1.5, and we get 0.405. I'll keep 3 decimal places on this one. That's it. So pay attention on your worksheets to how many decimal places they want you to keep, but essentially we're just using these, rearranging them into log form and evaluating.